So, good day everyone. No? This is a recorded video again. Module 4 nyo. So, from module 3 to module 4, ito yung pinaka-last na module no, about wind tunnels and reservoirs. So wind tunnels and reservoirs, ano lang ulit to? Recap, parang overview or review ng aerolab nyo and other parts like rockets and pitot tubes. So sa pitot tubes, di ba, about naman yun sa subsonic natin. And wind tunnels, yun nga, sa aerolab, rockets, and specific goals. So dito, no, i-apply lang natin relationship ng pressure, density, temperature natin to our Mach number. Since, no, from module 1 at module 2 na nasa current state lang tayo or current point, no, kung ano yung mga condition nila doon, nag-travel na tayo from module 3 from, kumbaga flow na siya from point 1 to point 2. So, dito sa wind tunnel, no, itatakal din natin yun, how to derive mga formula yun. But, ano lang dito talaga, review lang since na ano nyo na to, na lesson nyo na sa other subjects nyo, yung mga lower years nyo ng mga subjects. So, let's go, no? Let's go. So, no, sa module 4, no, about wind tunnels. So, wind tunnels are ground-based experimental facilities designed to produce flows of air which simulate natural flows occurring outside the laboratory. So, for most aerospace engineering application, wind tunnels are designed to simulate flows encountered in flight of airplanes, missiles, and space vehicles. So, ginagamit daw, no, yung wind tunnels natin sa mga experiment na kagaya niyan. Hindi lang dyan, no, about, pwede rin yun sa mga cars, di ba? So, type of wind tunnels, we have low speed wind tunnels, no? So dito sa low speed wind tunnels, no, where Mach number is less than 0.3 and on computations are assumed to be incompressible. So dito sa low speed wind tunnels natin, ginagamit siya for incompressible. So we have type of low speed wind tunnels, we have open circuit at closed circuit. So review lang, no? Sa open circuit, flowing air follows a straight path from the entrance to a contraction to the test section. So followed by the diffuser, fan, section, and exhaust of the air. So kanina, no, sa introduction natin, makita natin yung picture natin doon. So this, sa right side natin, makita natin yung open circuit natin sa wind tunnels. So also called Eiffel or NPL. So yung isa naman is closed circuit. So the air flowing recirculates with little or no exchange of air with the exterior. So ito yun, isa natin, no, yung closed natin. So sa aerolab nyo, study ng wind tunnels, same lang din yan. So review lang talaga to. Okay? So ano pa yung ibang type ng wind tunnels? So we have transonic wind tunnels. So these wind tunnels are special design to cover the transonic range of Mach numbers from 0.85 to 1.15. So a solution to the difficulty of preventing supersonic flow with a convergent divergent nozzle and low Mach numbers with low speed wind tunnels. So ito, combination siya, no, ng transonic speed natin sa aircraft. No? So sa isa naman, supersonic wind tunnels, these wind tunnels use the appropriate design of convergent divergent nozzle to achieve supersonic flow. So dito, no, di-design siya para bumilis yung flow natin. And then sa hypersonic naman, so ito from Mach number 5 to 15. So yan yung iba't ibang wind tunnels natin. So some parameters that can be measured in the basic wind tunnels, we have lift, drag, side force, pitching moment, yawing moment, and rolling moment. So yun yung mga ginagamit natin, no? I mean, kinukuha natin sa paggamit ng wind tunnel. So, ano lang, no, analyze lang. So, the meaning or kung ano nagpa-function yung tunnels, na malay nyo lumabas siya sa quiz or exam natin. Okay, so reservoir, flow through a nozzle. So, flow in a converging diverging nozzle is used on many purposes like supersonic wind tunnels, rocket or missiles, engines, atodides, shortened term for aerothermodynamic duct, and gas turbine engine. So this lesson So will be subject to the following constraint conditions. So perfect gas, isentropic flow, steady flow, quasi one-dimensional flow, and compressive air. So pressure in reservoir and exit pressure will determine the condition inside the nozzle. So exit pressure and back pressure will determine the exhaust plume. So yung exhaust plume, no, yun yung nakikita natin sa mga rocket dito sa exit nila. Yung nilalabas, no, ng combination natin sa sa exit pressure and back pressure. So sa back pressure, we have static, ambient, and atmospheric. So sa rocket yung sa nozzle, matatakal nyo din yan. So ito, overview lang siya. Di ko alam kung na-take nyo na siya or taking pa lang, no, yung sa rocket or sa missile. Siguro sa GTE, no, propulsion. So dito lang din galing yun. No? Kasi nga, from a supersonic, no, we use engines, no, para makaproduce ng thrust. So ano lang din to, overview ng GTE. Okay? So ito yung relationship, no, ng pressure density and temperature natin in Mach number. So from formula for subsonic isentropic flow, we have T2 or temperature 2 from your point 2 over your temperature 1 equals to pressure 2 over pressure 1 raised to K minus 1 over K no, sa isentropic, or equals din siya sa rho 2 over rho 1 raised to K minus 1. So makikita natin dito yung relationship into Mach number. So saan ang galing yan? No? So from energy equation lang din siya galing, no? Sa compressible. So we have specific heat at constant pressure, no, times your temperature 1 plus 1/2 V1 squared, or your velocity is equals to C3 T2, no, plus 1/2 V2 squared. So dyan lang yung galing yun, no? From energy equation to our enthalpy, our Bernoullis. So sa Bernoullis kasi, di ba, sinabi ko last module natin or lesson na yung concept na gagamit siya, no, para maging ma-apply siya sa compressible. So dito lang siya na-derive, na-equate lang siya. Then sa di ba dun sa stagnation point or total point, the velocity is 0. So natakal natin yun, no, sa module 3 natin. So dito, di-drive mo lang siya, kunin mo yung total temperature mo, no, your T2, no, yun dapat yun eh. Pero, di ba, sabi natin sa diagram natin dito, yung yung reservoir temperature natin is equals dun sa point na kung saan yung velocity natin is 0. So lalagay natin siya dito, kakancel mo lang yung total velocity mo into 0, then equate mo na siya sa energy equation. So total temperature of your temperature 1 kung saan point man siya, so is equals to 1 plus your V squared over your 2 specific heat at constant pressure times your temperature. So we know, no, na specific heat natin at constant pressure is equals to Kr over K minus 1. No? I-substitute lang natin yun. Then we'll get this equation. So we know na ang Mach number natin is equals to velocity over speed of sound. So i-squared natin yan, m squared, para matanggal yung square root sa baba, and then we'll get this formula. Then, no, i-apply lang din natin yan doon sa formula, no, sa density, and we'll get, no, pressure, total pressure over your pressure equals to total temperature over your temperature raised to K minus K over K minus 1. So basic algebra, ilipat lang siya, equate mo, and then we'll get yung formula natin, which is equated siya sa Mach number natin, and we'll get this pressure, your total pressure over your pressure is equals to 1 times 1 plus K minus 1 over 2 times your Mach number raised to K over K minus 1. So equate mo na siya, same lang din with your density. So ito yung magiging formula natin. So yung O or total, no, yan yung sign niya. So it's your choice, no, kung saan mo siya gagamitin, kung ano yung way mo, ano yung gusto mo. So maglagay ka lang talaga ng indication para hindi ka malito. Okay? Kung gagamitin mo yung formula na yan, related sa Mach number natin. Okay? So, nakuha yan nga, no, sa isentropic natin and into our energy equation, then constant heat, then our Mach number. So, dun siya nanggaling. And mamaya ipapakita ko kung saan nanggaling yung coefficient of pressure natin, no, dun sa module 3. Kasi dito lang din siya na-equate from formula na dito. Okay? So, sa flow in supersonic or subsonic converging diverging nozzle, so sinasabi dito no, sa subsonic speed, no, subsonic speed, yung converging, no, ito converging, we have a figure here, no, kasi may ibang nakakalimot din. So, converging, so kapag ang velocity natin, no, or yung speed natin, o pumasok yung flow natin dyan sa converging, tumataas yung velocity natin, bumababa yung pressure, bumababa yung density, and bumababa yung temperature, no, sa converging. So, sa diverging naman, no, sa diverging flow, yung velocity natin, no, paglabas niya, speed, babagal yung speed kasi lalaki yung area, yung pressure natin tataas, yung temperature natin tataas din, and density is tataas. So, sa natin, supersonic, we have converging. So, sa velocity, is conceptual din naman. Review sa ano nyo, sa aerolab nyo, which your velocity pag dumaan yung supersonic sa converging, bumababa yung velocity natin. Bakit? Kasi nagkakaroon ganyan ng barrier, no? Or your supersonic speed, no? Kung saan yung Mach number mo is equals to 1, no? Bumabagal yung velocity natin. Then our pressure rises, temperature rises, and density rises. And then sa diverging naman, baliktad din yung nangyayari doon. So paglagpas niya, bumibilis yung speed natin. Supersonic siya galing sa supersonic. Bumibilis yung supersonic natin, no? So the velocity rises again, the pressure drops, and temperature and density. So dito no makita mo yung figure na kung saan ginagamit yung subsonic flow and supersonic flow natin sa isang wind tunnel. So nakuha ko yan sa NASA, yung figure na to or picture na to. Okay? So conceptual lang din yan kung ano nangyayari sa supersonic and subsonic flow natin kapag dumaan siya sa isang wind tunnel. So we have additional formulas ng temperature Mach number relation, same lang din dun sa kanina, which no temperature 2 over temperature 1 is equals to K minus 1 m squared plus 2 over your K minus 1 m2 squared plus 2. So inequate mo lang no yung ano mo, yung dalawang temperature and dito sa isentropic flow natin, para nag-substitute ka lang. Since nakakita natin, yung your total temperature over your temperature is equals to 1, i-equate mo lang siya, plus K minus 1 over 2 m squared. So, same lang yan dito, kung paano siya na-equate. Okay? So, review lang, no? So, density, same din sa density natin, no? May raise lang siya ng 1 over K minus 1, and then we have sa pressure, which is K over K minus 1. Okay, so sa total temperature natin, temperature and density, ito yung summation, no? Summation, yung summary ng formula natin, which is ginamit natin kanina or inequate natin kanina. From here, no? Same lang din yan doon. Okay? So, yan yung ginagamit natin or relationship ng temperature natin from point to point, no? Pressure and our density. So, area Mach number relations naman, makukuha natin area 2 over area 1. So, nakuha lang din yan no, sa flow natin no, sa energy equation na, di ba, we have, no, kung maalala nyo, we have area 1, density 1 over your velocity 1 is equals to your area 2, density 2, and your velocity 2. So, equate mo lang yan, no, sinabi dito na area 2 over your area 1. So, basic algebra, lipat mo lang siya, divide mo siya sa area 1. So, makakuha mo yung density 1 over your density 2. Then, we have velocity, which is V1 over V2. So, di ba may naalala ko yung relationship natin sa isentropic, no? Isentropic relation, na kung saan ito rin yung value niya. So, i-input mo lang yan, no? May cancel din dyan. So, mahaba siya, guys. So, yan, summary na lang. So, di ba maalala natin no, sa velocity natin, no, sa isentropic natin. So, saan yun? Papakita ko lang kung saan siya galing. So, sa velocity natin, di ba? May K minus 1 din yan. Okay? So, relationship lang yan, no? Na, from our isentropic relations and to our Mach number. So, equate lang yan, guys. Okay? So, balik tayo doon, no, sa formula natin, which is sa may area. Okay? So, doon yan nakuha. Kung gusto nyo mag-equate, okay lang naman. Kung nakalimutan nyo siya, so dito na siya galing, dito na siya. So, P1, ganyan, P1. So, P2. Oy, row 1 over row 2. So, baliktarin mo lang yan, ito. Kasi pag binaliktad mo yan, same na yun sa K minus 1, etc., etc., so on, so forth yan. So, dyan yan nagaling. And then, no, we have throat section area Mach number relation. So, this formula simply uses the area Mach number relation formula. Then, assuming, no, sa M1 is equals to M throat. So, throat yung may asterisk, no, is equals to your sonic. So, dun yung speed mo, kung saan, dun yung area mo. So, pag sinabing, what is your area, the throat, so, yan yung gamitin mo, no. Assuming na din na yung Mach number natin is 1. No? So, magagamit mo yan, no? Na kung saan may point-to-point mo siya. Okay? So, yan yung gagamitin mong formula. So, relationship lang din yan na Mach number natin to our continuity energy equation and yun, sa mga energy equation natin. No? Next, no? So, may sample problems dyan. Dito nilagay yung sample problem since no? Sa module nyo, gagawin ko siyang recitation para dun sa mga hindi pa nakakapag-recitation during their GT. So, i-create ako ng Google form, i-send ko siya. So, yung mga nakapag-recitation na, hindi na sila mag-fill up no? Sa Google form. So, may list naman ako doon kung sino yung mga recitation. Okay? So, try to review dun sa sample problems. Siguro mga 2 or 3 lang lalagay ko since i-open ko siya para masagutan nyo no? Dun sa mga nag-OJT. So, 10% lang naman din yun. Okay? So, next, we have P2 tube and total value. So, if the flow is not constant over a given cross-section, so for example, if the flow velocity in the middle of the section is higher than near the walls, no, then our velocity to obtain from the preceding section is on the mean value of the test section velocity. So for this reason, for many other aerodynamic applications, so it is important to obtain a point measurement of velocity at a given spatial location, the flow. So this measurement can be made by an instrument called electrostatic tube using pressure difference. So sa aerodynamics too, no, as far as I remember, no, nasabi na paano nakuha yung electrostatic tube natin, which is meron tayong static pressure, dynamic pressure, linear total pressure. So obtains point measure of velocity at a given spatial location, the flow by pressure difference. No, you have your total pressure minus your pressure. So it's either static or dynamic. So yan yung measurements natin. Okay? And then, no, mayroon tayong 2 types, no, ng electrostatic system, no, the pressure na ginagamit, and is the static pressure. So if the pressure we would feel if we were moving along with the flow at that point, it is the consequence of just the purely random motion of the molecule. So when an engineer or scientist uses the word pressure, it always means static pressure unless otherwise identified. So sinasabi naman yan kung anong klaseng pressure siya. So kapag lumabas sa problem, no, kapag sinabi pressure, then static pressure yun, no? Unless nga identified siya like your dynamic or your total. So a second type of pressure is commonly utilized in aerodynamic, namely total pressure. So imagine that we grab a fluid element, streamline it, and slow it down to a 0 velocity. So sinasabi diba natin sa point which is yung velocity natin is 0. So the thermodynamic properties, no, that we have, pressure, temperature, and our density of the fluid element will change as we heat the element to rest. So they will follow the conservation laws we have discussed previously, no, as the fluid element is isentropically brought to rest, yung mga parameters mo would all increase above their original values when the element is moving freely along the same line. So the values of thermodynamic parameters or properties, the fluid element as it has been brought to rest are called total values. So wala kang velocity doon. So kung ano yung condition ng pressure, temperature, density mo. So yun na yan, no? Where the velocity flows is 0. Then, no? So type of pressure dito, nilagay ko lang to. Actually, wala to sa module. Nilagay ko lang siya for additional knowledge, no? Since review lang talaga to, no? So na-discuss naman yan. So static pressure, yun yung random motion of molecules, no? Pressure of a non-moving air. So pressure felt if we are to move along with the flow at that point. So yun yung static pressure natin. Yung total pressure naman, no, stagnation laws, in fact, or P2, existing pressure if a flow is to be slowed down isentropically. So all kinetic energy has been converted into pressure energy. So we have velocities, also measured by P2 tube instrument. So special case, which is your total pressure is equal to your static pressure when the velocity has no velocity in the first place, such as stagnant air in a room or gas confined in a cylinder. So dynamic pressure naman, no, we all know that the dynamic pressure natin is the pressure resulting from its motion. So we have 1/2 rho v squared. So sa liquid, di ba? Maalala niyan yung dynamic pressure natin. So we have type of airspeed, simplified airspeed, no? Not corrected for any errors, calibrated airspeed or rectified airspeed. We have indicated airspeed, corrected for instrument and position errors. And then we have equivalent airspeed, calibrated airspeed, corrected for compressibility effect. Then true airspeed, equivalent airspeed, corrected for density. So yung mga different types of airspeed natin. Okay, so we have a sample problem here. Sabi dito, a high-speed subsonic aircraft is flying with a velocity of 160 meters per second at an altitude where the pressure and temperature are 100,000 pascals and 250 Kelvin. So, calculate the pressure of the stagnation point. So, hanapin natin yung pressure natin at stagnation point. Assume na yung universal gas constant mo is 287.08 and your specific heat ratio is 1.4. So, dry air yan. Okay? So first, no, ilagay muna natin, we have temperature, pressure, velocity, your universal gas constant, and your specific heat ratio. So required, hinanap natin yung stagnation point, no, kung sa pressure natin, which is your P2. So gagamitin natin yung formula natin from our pressure Mach number relation sa isentropic. So una, hanapin natin yung speed of sound para makuha natin yung Mach number natin. So equating, no, sa speed of sound natin into our Mach number, since given tayo ng speed, we'll get our Mach number, which is 0.5, 057, 59, 9886. So store function mo siya. And then, no, input mo siya sa ano natin, sa formula natin, which is hinanap natin yung P2 o yung sa stagnation point. So from point, no, from point 1 to point 2. Okay, so pwede natin magamit itong. So just equating the formula, 0.2 is equal to 0.1 times yung napaloob doon, which is k minus 1 times n squared over 2 plus 1. So raised to k over k minus 1. So input, no, direct input ng mga given, and then we'll get our pressure at the stagnation point, which is 118,999.8704 pascals. So yun yung pressure natin at your stagnation point. So, magamit na siya dyan. And then, no, next problem. So, if you want to solve, just pause the video, read, and try to solve. Okay, so, sinabi ko rin kanina, no, malay nyo, ilabas ko din yung tulog ito sa mga nag-OJT para sa recitation lang. So, an aircraft is flying at an altitude with an ambient pressure of 265 pascals. A P2 tube mounted on the wingtip measure a pressure of 424 pascals. So calculate the Mach number at which aircraft is flying. So assume na yung K mo is 1.4. So given tayo ng dalawa, we have pressure 1 and pressure 2 na kung saan sinasabi na yung isa is ambient pressure and yung isa naman is from your P2 tube. So, use the formula lang doon, no? Gamitin natin doon yung pressure. So, pressure 2 over your pressure 1 is equals to K minus 1, m squared over 2 plus 1 raised to K over K minus 1. So, yun yung gagamitin natin, no? Na formula. So, input lang din, no? Equate natin yung pressure natin, I mean yung Mach number natin since hinahanap is yung Mach number. So, record is the Mach number. So, equate mo lang, ilabas mo na yung Mach number, then we'll get the 0.8477. So, basic algebra lang din, no? Ano lang, transpose, same lang din sa ginagawa nyo sa module 1, module 2, module 3. Okay, so dito, sa formula, no, direct input, kung sa alam mo paano mag lagay yung formula, basta kabisado mo siya. Okay, and then, no, next na is sa rocket. So we have thrust. Thrust is a reaction force described quantitatively by Newton's second and third law. So it is the force that moves the rocket through the air and through space. So the Delta's equation, meron tayong formula, which is our thrust is equals to mass flow rate. No? Your mass flow rate, ito, no, times your velocity at exit plus, no, yung pressure difference mo from your exit and back pressure, which is your ambient. Sa kanina, no, nakita ko yun sa exhaust plume, no, yung back pressure, tsaka yung pressure at exit, and then we have area exit dun sa ulo natin. So, itong first part na to, ng equation natin, no, so this is our momentum thrust, and this is our pressure thrust. So, try to remember, no, kunyari, bigay din sabihin ko, find your momentum thrust or your pressure thrust. So, alam nyo kung saan siya, no, dun sa thrust equation natin or sa rocket thrust equation. Okay? And then, no, we have specific impulse. So, specific impulse is a measure of how effectively a rocket uses its propellant or a jet engine uses its well. So, it is a measurement of efficiency of a rocket engine. So, it is expressed in terms of impulse per unit mass or weight. So, depende yan, no, gaano siya, I mean, kung ano yung ano natin yung specific impulse natin by mass ba or by our weight. So impulse is defined as the integral force, no, thrust over time travel. So we have specific impulse, no, integral of your force times your time. So per time kasi yun, no, kung gaano siya kalayo, no, yung tina-travel niya. So we have impulse per unit mass, which is specific impulse, which equals to our impulse over our mass. So we can equate, no, force times our time times our mass is equals to force times our mass over time. So which is, this is our mass flow. So yung impulse per unit mass natin is equals to specific impulse equals to force over mass flow lang. No? So yan yung impulse per unit mass natin. And then, we have impulse per unit weight. So, direct lang din, no? Ito naman, no, pinagbago lang is weight, no? May gravity tayo sa, kasi di ba alam natin na mass is just mass like kilograms or slugs. Sa, ano naman, sa weight naman, we have Newton, no? Or pound force. So, our specific impulse is equals to our impulse over your weight. So, equate mo lang, alam natin na yung impulse natin is equals to force times time over our mass times heat. So we have force over mass flow times your gravity. So by doing unit cancellation, we can determine the unit of impulse per unit weight is second. Okay, so yun lang yun. So may clear talaga, no, yung module 4 nyo. So mayroon kayong activity ulit, no, technical report nyo, no, modular activity, no. So, konti lang yung questions na yun, kaya-kaya nyo siya i-solve. But, mag-a-announce ako, no, kung kasi di ba may mga OJT, so hindi sila ng, kumbaga sana mabawasan yung workload. So, pag-iisipan ko yun, I'll post it on your Google Classroom together with this video. Kung ilan na lang, no? Or actually guys kasi talagang pang-practice ito. Yung ano natin, yung modules natin. Kasi kapag normal shock wave na tayo, tsaka oblique shock wave, lahat-lahat yan sama-sama ang isa. So, dun yung magiging concept natin. So, try to review your module 4 tsaka module 3 from your quiz 2, nung magkakaroon tayo ng quiz 2. And then, siguro dadalhin na lang namin no, para hindi rin kayo mahirapan. So, dito sa so it's about wind tunnels na naman and reservoirs. So, sana maalala yung mga formula. So, we have formula for subsonic isentropic flow. So, relating lang sa Mach number natin. So, from energy equation siya. Okay? So, madali lang naman siya i-deal. Kasi, review lang din naman ito ng past subjects nyo. Third year nyo. And second year. So, good luck, no? So, yun, doon na tapos module 4 natin. Then, this is the last module na natin. So, mag-announce na lang ako. So, kung may mga questions, ay, okay pala. So, doon pala hindi pa natatapos. Naalala ko. So, dito sa, nakuha natin yung, we have density Mach number relations. Doon sa CP, may tatanong sa kasi kung paano na-derive yung CP, and paano makuha kapag hinahanap yun. So, ito yun, guys. Itong temperature Mach number relations natin, density and pressure. And sa CP kasi natin, sa CP, which is ito, dito siya galing. Nag-substitute lang tayo dyan ng ano yung mga parameters or equations na pwede natin magamit. Tapos, sinalpak lang siya dyan. Kasi hindi ba maalala ito sa temperature na natin, no? So, CP, no, from dito lang siya, from dito, okay, 0, sobrang, ano niya, sobrang tagal niya i-solve. Like this one, Mach number, kung paano daw hanapin yung Mach number, then, gusto niya i-try, no? Pwede naman, no? Pero sobrang haba niya. And ako din, tatry ko siyang i-solve, no, from equating mo siya sa Mach number. Kaya. So, no, from doon na siya galing no, from relationship ng thermodynamics, thermodynamics relations from our Mach number. So, dito, dyan lang siya na-equated. Okay? So, dun sa nagtatanong, paano siya na-equate? Mahaba kasi ito. So, ako na ito na lang, direct na lang tayo kasi application na from our Supersonic. So, you don't have to equate pa or derive. Siguro kung nakalimutan. But for me, mas mabuting aralin mo na lang ito kasi sa mag-direct ka kasi time consuming siya. Kagaya ng sinasabi yun, kung sasagot ng modules, pumayag na ako mag-shift solve para mahanap yung Mach number nyo. Okay? So, yun lang yun, yung topics natin from our module 2. So, if you have questions, no, ito yung sakop no, ng magiging quiz to natin. So, good luck no, good luck sa magiging quiz, long quiz nyo, and your prelim exam. So, medyo madali lang naman siya since ito lang naman yung mga topic natin. So, master the basic formulas, basic fundamentals, and basic concepts ng ating thermodynamics, subsonic, and dito sa supersonic na ating mga nagiging pagbabago once dumaan siya sa wind. So, yun lang guys. So, thank you no, for watching and wala tayong makasagot. And alam ko kaya-kaya mo. So, good luck no guys. Ask na kayo ng questions kung may mga doon. Okay? Bye. Ingat lagi.